Hi guys, in this video we're going to have a look at composite functions. This is part 2, so definitely make sure you've had a look at part 1 because that's going to definitely help us in this video. So, what we looked at before in part 1 is when you substitute a particular value in or input a particular value, whether it be an integer or something like that, and what you get as an output. In this particular case, what we're having a look at is substituting in different variables such as x squared or x plus 2, and getting an actual expression out. So let's have a look and see what we can do. So here we go, is the first one. This is our function, 4x plus 3, so this is the same as what we've seen before. But it says this time I want to find an expression, so not actually finding any outputs in this particular case, just finding an expression for if you do 2f of x. So all this means is I'm doing 2 times f of x. Well, f of x is 4x plus 3, so all I'm going to do is times the f of x, which is this, by 2. So I'll put it in a bracket first. And of course, when you put it into a bracket, and when we're times in, I'm just going to expand that bracket. So here's me expanding it. 2 times 4x is 8x, 2 times 3 is 6. So 2 of f of x will just be 8x plus 6. Simple as that. In this particular case, we're actually going to put or input x squared into the function. Okay, so it's not on the outside like this one. We're actually going to input x squared. So all I'm going to do is I'm just going to put brackets around the x because that's where my input is going to go. So if I write this out, I've got 4, then I've got my bracket, and I'm inputting x squared. So I'm going to replace that x with this x squared, close the bracket, and then plus 3. All I'm going to do then is just simplify it. Well, expand this bracket. Well, that's just 4 times x squared, which is 4x squared. And of course, I need to add my 3. And you're done. Simple as that. Just substituting or inputting x squared into that function. Same thing with this one. Instead of being x squared this time, it's x plus 2. So I'm going to input that into there. So I've got the 4. Then it's the bracket and x, well, I'm inputting x plus 2, close the bracket, and I've got my plus 3. So exactly the same as here. All I'm going to do is expand this bracket. So x plus 2. So I'm going to have 4 times x, which is 4x, 4 times 2, which is 8. So if I write this out, after I've expanded the bracket, I have 4x plus 8, and this is where people are going to forget to do. You've still got this plus 3. All I've done at the minute is just expand that bracket, but don't forget you've still got the plus 3. And of course, then you can just simplify that. 4x and 8 plus 3 is 11. Okay, so all you're doing is substituting in or inputting the values that are inside here, unless it's on the outside, in which case you do what we did there. So here's another function. This time it's g of x, and this is 5x minus 2. And again, I'm going to find some expressions for doing different things. So let's have a look at this one. This time, again, it's on the outside. So I've just got my g of x, and whatever g of x is, I'm just going to take away 2. Well, g of x, we know, is 5x minus 2. So that's that bit done there. And then I need to take away another 2. All I'm going to do then is to simplify it. Well, I've got my 5x, and then minus 2, take away another 2, is minus 4. So 5x minus 4. Because it's on the outside, I just keep the function the same and just take away 2. These two, just like over here, they're actually inside the bracket, so I'm going to actually input these into the function. So again, I'm just going to stick a bracket around there because that's what I'm inputting into there. So I have 5. Then I have my bracket, and this is what I'm inputting is the 2x. And I'm going to close my bracket, and then obviously it's the minus 2. So expand the bracket. 5 times 2x is 10x, and then I've still got my minus 2 there, and that's your answer. 10x minus 2. And last but not least, this one here. So again, I'm going to input x minus 1 into those brackets. So 5 bracket, then I've got my x minus 1, and I go back up here, and don't forget to take away the 2. Expand the bracket just like we did on the previous one over here. 5 times x is 5x. 5 times minus 1 is minus 5. Write it out up here. So I've got my 5x minus 5. And again, you've just expanded the bracket here. Don't forget that take away 2. And then simplify this. Well, that's 5x minus 5 minus 2 is minus 7. So 5x minus 7 is your final answer. So that's some of the more basic examples. Let's delve into some more trickier ones. So in these examples, I have two functions together. I have f and g of x. So in part 1, you'll have seen me inputting a value into g of x, into function g, and then putting that new value into f. Here, I'm just finding an expression, but it's no different. I'm going to input g, in this particular case, I'm going to input g into f, because g needs to go into f. So let's get started. First thing I'm going to do is I'm going to put a bracket around the x on the f function, because g is going to go into that. So there's the bracket, and then I need to input g, which is this, into there. So inside the bracket would be 5 minus 2x, and then I go back up here and I've still got my minus 1. Okay, so all I'm going to do is just simplify that. Well, there's nothing on the outside, not times in this bracket, so it literally is 5 minus 2x minus 1. So 5 minus 1 is just 4, and then I've got my minus 2x. So it's simple as that. 4 minus 2x. Now, this is the other way around. So this time, I'm going to put f, so this function, inside the g. So I'm just going to put a bracket round there, because I'm now going to input x minus 1 into there, because f is going into g. So let's write out this then. So g is 5 minus 2, bracket. Now I need to input this. So inside the bracket is the f, which is x minus 1. And that's it. So, just like before, we've got some brackets. Let's expand them. So, be careful. That's a minus 2 on the outside. So, I'll put minus 2 on the outside, and then x minus 1 on the inside. Minus 2 times x is minus 2x. Minus 2 times minus 1, well, that's a minus times a minus, which is going to give me a positive, and obviously 2 times 1 is 2. So let's go back down here and write it out. Don't forget you've got the 5 still, then the minus the 2x plus 2, which you just expanded. So a little bit of tidying up and simplifying. 5 plus 2 is 7, minus the 2x. So the answer there, 7 minus 2x. Okay. So another couple of examples on this. This time I've got a different function here. F is 2x plus 1 and g is 4x plus 3. Again, let's have a look at this. So g is the first one, so I'm putting g into f. So I'm just going to put a little brackets around the x there, because I'm putting that into those brackets. So 2 bracket, then I'm putting g inside it, which is 4x plus 3, close the bracket, then go back over here, and I've still got a plus 1. So again, I'm just going to expand this bracket. Two times 4x is 8x. 2 times 3 is 6. So then I've got my 8x plus 6. Don't forget the plus 1. So a bit of simplifying there gives you 8x plus 7 as your final answer. And last one for this particular page, this time just like over here, I'm putting f, so I'm putting f into g. So again, I'm putting brackets around g, because I'm going to put 2x plus 1 inside those brackets there. So I've got my 4, then my bracket, then I'm inputting the 2x plus 1 into there, closing the bracket, and I've got plus 3. So again, expand the brackets. 4 times 2x is 8x. 4 times 1 is 4. Bring it down here. And don't forget the plus 3. You've expanded the brackets, but don't forget the plus 3. Bit of simplifying. 8x, 4 plus 3 is 7. Okay, simple as that. So that's when you put the f of g's inside. Let's have a look at still the same sort of thing, but just a little bit more trickier. So last two examples, just when we've got an x squared here. So again, I've got f of g, so g is going inside of f. So I'm just going to put brackets just around the f. Notice I haven't included the squared there, I've just put it around the x, and that's what g is going to go inside of. So I've got my 2, then I've got my bracket, and this is where the g goes inside it. So x plus 3, close the bracket, and it's squared. Okay, so I've got 2 times this. Now I'm going to do the squared first because I've got my indices first. So I need to do x plus 3. Remember, squared means times by itself, which is x plus 3. So this time I'm expanding double brackets. So I'm going to do my slightly bigger grid over here. X plus 3, x plus 3, so x times x is x squared, x times 3, 3x, x times 3, 3x, 3 times 3 is 9. A little bit of simplifying, that gets me to 6x. So let's write it all out. I've still got my 2, which is there, and then when I expand these double brackets, I'm going to have my x squared plus 6x plus my 9. Once you've done that, you can then expand this bracket by timesing everything by 2. So I'll expand this bracket. So 2 times x squared, 2x squared, 2 times 6x, 12x, and 2 times 9 is 18. So your final answer, 2x squared plus 12x plus 18. Okay, so take your time with that one. Make sure you expand the brackets. If you can't remember how to expand brackets, just look at the expanding brackets videos. Obviously, single brackets here and double brackets there. And that should be okay. And the other way around, so this time I'm going to put f into g. So again, I'm going to put little brackets around the x then, because that's where the f is going into. So obviously, I'll have my bracket straight away. 2x squared, close the bracket, plus 3. Nice and easy, this one. I'm not expanding the bracket, I'm not timesing the bracket by anything, it's just 2x plus 3. Simple as that. Sorry, 2x squared plus 3. Okay, so just an example there with an x squared. So hopefully that helps you with funny expressions with these composite functions. Cheers for watching. Cheers, guys.